Hi, today I'm going to do a design in Fusion 360 for a parametric Lego block design. Now, the reason why I'm doing this is because sometimes I do Lego projects and I will need a custom part to put a PCB board onto a motor or a switch or something to that effect. And I wanted an easy way of creating a base block and then designing or making alterations to the block after that. So that's what this design is. It's very nice and easy. It's got 3 user parametrics in it, or parameters in it, and as I change those, I can alter the size of the block, both length, height, and width. So that all works rather well. It's actually a very simple design. I learned a few things along the way, and so without further ado, let me take you through how to do this. So we'll start off with a new design, and as always, a sketch. So first, dimensions. I did some searching on the internet to see what dimensions people had done, and there's, as you can imagine, there's lots of them, some accurate, some not so accurate, some rounded up. But the one I liked the most, which was the easiest to work with, was this one by Christoph down in New Zealand. And he put together, also in Fusion 360, these drawings and dimensions. So the PDF file is here. The link to this site will be in the description. You can download the PDFs here, and he's also uploaded them to GrabCAD. So if you go into there, you'll see there's an STL file for a 2x4 brick where you can download that. Now I did download this and I printed it, and it worked out very well. That's the Lego brick there, and it all works very well. So I was happy with the dimensions and the way he put this together. But as I say, I wanted a parametric version, and so that is what this video is about. So dimensions are fairly simple. We've got the stud at the top here is 1.8 mils. We've got a full-length brick at 9.6, and each a platform, or at least a base at 3.2, so a unit height is 3.2. We've got a dimension of 3.9 millimeters between the center of the stud and the edges of the wall, and 8 millimeters between studs. If you notice here, the dimension, the brick length is 15.8 and 31.8, and that 0.2 millimeter really is there's a 0.2 millimeter gap between bricks, so you've got to have that in. So what I learned largely about doing this one, which I'd failed in my original design, is how to do the dimensions in a way that so when the brick grows, you still maintain that 0.2 millimeter gap between bricks. And I found the way to do that, the best way to do that, is to take one stud and anchor that in one place, and this wall and that wall, and anchor that, and everything else grows out from there, and the calculations work out. So let's go from there. We're going to start off with the stud. Well, this stud over here is going to be my anchor, and it's a 4.8 millimeter diameter. So create a circle, 4.8 millimeter. Okay, first stud in place. So I'm going to start off with extruding that, and we're going to go, that is going to be 1.8 millimeter. And I'm just going to try and remember to name all these things so that I can refer back to them in the parametrics. Stud extrude. All right, so there's our first stud. Now the next thing I'm going to do is set up the user parameters, and we only need 3. We need a unit length. It doesn't have a particular unit, it is a unit, and I'm going to design it as a 2x2 because it makes it a bit easier to work with. This is a unit. So by unit here, I'm talking about the number of studs in the block. To there. Unit height. Again, no units on that, and it is 1. Okay, so that gives us our start. So first thing to do then is to create the pattern. Now I've got these pinned up here, but if they're not there on yours, if you go down to, where's it got to, pattern, rectangular pattern, and then there's these three dots, which is the menu, and you can pin it to the toolbar. So I've done that for the pattern and the parametrics, just to make life a little bit easier. So first thing, I'm going to do a body. That's the body I'm doing. Directions, I'm going to choose that orientation of the axis, and that way, and then we're doing up. So I know from the design that it's 8mm between studs, and this is going to be the unit. Hang on. It's going to be the unit width. I'm going to do so. The vertical line is going to be width, and the horizontal this way is going to be the length. Now, the distance type, this needs to be set to spacing because it's the 8mm spacing between the studs that we're concerned about here. Let's move that over there. And for the other way, it's going to be the same thing, but that is going to be the unit length. So you can see how it brings up the parameters that I've got in there as our type, which is quite useful. And 8mm for that as well. There we go. So that gives us our first part of the Lego block. The next thing we need to do is the inside support, or this, I don't know what you call that, but it's this bit over here, this bit here. So these are the bits underneath that the studs lock into. And again, this is pretty simple. It's a 6.51 diameter, inner diameter 4.8. Now, I generally make that a bit bigger just to handle with the shrinkage, especially with that small size diameter, to handle the shrinkage. I'm just making that a bit bigger so that the studs actually do fit in. But generally, you don't really need that. It's the diameters in here so it's this diameter, the 6.51, that's actually more important. So this becomes fairly easy as well. We've got, these are also 8mm between, and these are 8mm between. So if we're putting one of these in here, it's going to be half that, so it's going to be 4mm. That central point there is going to be 4mm. So again, nice and easy. Back to the sketch. Grab another circle, and that, what did we say? 6.51, I think. Is that right? 6.51. And then we can just put some dimension constraints in. So that we said was 4mm, and between there and there in that direction is 4mm. And that fits in nice and snug. Now, part of the anchoring again, so what we've got here is we've got this stud anchored to the origin. We've got this anchored to the stud. We now need to do the anchoring of the walls. And again, as I said earlier, this wall here and this wall over here, we're going to anchor to this stud. These ones here are the ones that are going to grow. So fairly simple again. We go back to here. Our dimension between the center of the stud and the end of the wall, or the outside of the wall, is 3.9mm. So dimension between there and there, 3.9mm, and between there and there, 3.9mm. Then the wall thickness is 1.2mm. So for that, I'm going to do an offset, 1.2mm, and then that will follow the design. Right, now we need to calculate the outside wall of this. Now that's fairly simple as well. It's going to be the number of studs that we're going along, plus this. Actually, it'll be the number of studs minus 1 plus this distance is 3.9mm distance. And as I said earlier, this 3.9 figure is important because you need a 0.2mm gap on either side, so between bricks, so you need a 0.1 on one side and a 0.1 on the other side, and that's why this is 3.9 and not a straight 4. So this, we put another dimension in there, and this we put in as a calculation. So we want the unit length minus 1, and we want to multiply that by our 8mm spacing between studs. So keep the brackets in place so that everything stays right, and then we want to add in 3.9mm. So that 3.9mm we're adding in there is the other half of this diameter that we've got over here, or this dimension between the stud and the center of the stud and the wall. So hopefully that makes sense. And we do the same for this one. We go between there and outside wall. 2 brackets this time. Unit width -1 times 8mm minus 3.9. Oops, that definitely didn't work. What did I do wrong here? That should be plus 3.9. There we go. So that looks about right. Yeah, we've got the dimensions in place. So the next thing to do is extrude it. So if I just switch the sketch on, Q for extrude. Now we're going to extrude downwards because that's the way we're going. And we're going to extrude. I'm just going to do, because what did I do? I set the parameter as a 1 unit height. So we know 1 unit height is 3.2mm, so this is going to be 3.2mm multiplied by the unit height. No tapers or anything like that, and we do it as a new body. Hang on. That needs to be minus all of that to make it go down. Right, there we go. That looks a bit better. Then we need to handle this inner part here. So I have left out, let's rename this to outer wall extrude. Now back to the sketch, because we need the inner part of that. The inner diameter, where did we get to? Inner diameter was 4.8, but as I said, I'm going to make it a bit bigger just to handle this shrinkage. All the other dimensions I'm leaving exactly the same. I just know from printing this out that this needs to be a bit bigger. So I'm going to do that at 5mm. Close that. Now we need to extrude it, and it's the same thing. Now I can put the formula in here as well. I can do it 1 times the unit height, or 3.2mm times the unit height. But in this case, I'm going to link it to the outside wall and do it as a new body. So every time the outside wall grows, so the inside, these inside pillars will change as well. So that's looking pretty good. Now the next thing we need to do is the pattern for this. So and a quick test, always a good test. Let's change this to 3. That's looking good. 3 by 3, there we go. That's looking fine. So what we're going to do is we're going to flip this over. Do we need to flip it over? Yeah, we can flip it over. There we go. Just so we're looking at it from the bottom. This is our anchor point now on this side because we flipped it. And we're going to go into pattern. Again, we're going to select that body. Directions, we're going up and left in this case. It's a spacing. Quantity is going to be the number of studs minus 1 again, because we're going in between the studs, so that's going to be -1. So this is the width direction, so unit width -1, and it's 8mm, and this is going to be unit length -1 and 8mm. Okay, so that's all looking very good and nice and easy. Got that up there. Now the next bit we're going to do is this bit here. So in my original design, I just did a wider wall, and it really didn't work. The press fit didn't work very well. I wasn't happy with that. So I'm going to go with the design that's on here. What I'm not going to put in for this version are these 2 supporting walls over here. I could do, but I'm not going to bother at this stage. But these ones are very important. So it sticks out by 0.2 mil, and it is 0.6 in width, and they will line up exactly with the edges of these studs on the walls. The difference here with the pattern is that we've only got they only go along the inside of the outside wall, if that makes sense. They don't, usually with a rectangular pattern, it'll do a whole rectangle. So for this one, we'll do 4 patterns for each part of the wall. And yeah. So back to the sketch. Let's turn. Doesn't really matter, but just for my own sake. Right, so we're going to put in 2 of these. That is going to be, now I'm doing this at 0.3 again, and 0.6. Again, just because this distance between here and here is actually 0.3, and it works well with the 3D print. So put that there. Now we can do a collinear between that one and that one, and then we need to set the dimension. So how to get this centered correctly on the midline of the stud. This is 0.6 millimeters. We know that this is 3.9 millimeters, so half of 0.6, which is the midpoint of this, minus that is 3.6. So the dimension between there and there is 3.6. There we are, and that's nicely in the middle. Let's do this one. That is, what do we, 0.3 and 0.6. Is that right? That looks a bit big. Collinear, no, that's fine. And dimension from there to there again is 3.6 millimeters. Okay, so then we will do this side. Now I'm going to do opposite corners. So we'll do a pattern to grow this one along that way and a pattern to grow that way, and then we'll anchor these bits on this side and we'll grow it that way and that way. That seems to work rather nicely. So let's just put those in. It's going to be 0.6 and 0.3. Let's just put the other one in. That is going to be 0.3 and 0.6. Collinear between there and there. Collinear between there and there. And a dimension between that one and that one of 3.6. And between that one and that one of 3.6. There we go. That's that. Now we need to extrude them, and we can extrude them in one go. So Q for extrude. We want that one, that one, that one, and that one. We've got 4. That's looking good. And again, I'm going to extrude them to link them to the bottom of that, and make sure you change this to new body, because if you join it then the pattern doesn't work. There we go. So we've got a whole lot of new bodies. You can see our bodies are growing. Excellent, that's looking good. So now to do the patterns, so let's do this from the bottom again. And right, so we're just going to do one of them in one direction. So we're going to go up in this direction, and that is also going to be 8 millimeters spacing between the two, because again that's the stud spacing, and the quantity is going to be the number of studs. So in this case, units height, unit width. And this one going this direction. Choose a direction that way. 8 millimeters units length. So there we go. That's those. So that's that side and that side done. Now let's do this side. That's that. Our direction is that way. Except this is now going to be minus, not 80, minus 8 millimeters, and this is going to be units length again. And last one, there, and that is going to be, let's get our direction, that direction, and -8 millimeters with a unit width. There we go. That brings all that in. So that again is looking good. The last thing we need to do is the floor, and the dimension of the floor is 1 millimeter. So we can do another extrude. We're going to grab that, and we need to add in, because these are the sketch parts, we need to add those bits in as well to make sure we get everything there. It's a new body, and the distance is going to be -1 millimeters because we're going down. We don't want to cut, we want to do a new body. There we are. And there's our Lego block. Nice and easy. Go back into the parametrics. It's changed. Well, let's test it. 2 by 2. That's looking good. 2 Lego units, 3 Lego units, 7 Lego units. There we go. That's quite a Lego unit. Oh, 73 Lego units. I thought that was a bit big. 7 Lego units. There we go. That makes more sense. There we go. So that's working very well. Now, let's just save that design. So, demo parametric block. So this is where the beauty of this comes in. So let's say I need to make a custom plate for a PCB board. I need to make the space and set the dimensions to the right size. And so we can do that now. Create a new file. Let's just call this, say this is demo. So I can take my design that I've just done and drop it in there. And if we go into the parametrics here, you'll see there are no user parameters. And the reason for that is that it is still linked. So you have to unlink or break the link between the two in order for that to come across, because the parameters are in the original design, this demo design that we've just done here. So we've got to break that link. So just right click there, break link, and now they're separate. And if you go into here, there are all our parameters and there's all the dimensions that we put in. So just for ease of use, I'm going to put that back to 1. And let's make this a 7 by 8 for argument's sake. So just as a demo, that gives us the size board we want. So if we're going to put a PCB board onto this, we want to get rid of some of these studs. You might want to put a cooling hole in or something to that effect, but we need to be able to control these. So if you go down to the group here, there's all the patterns that we put in earlier. So there's the first one is our studs, and that's the one we want to target for the top, edit feature. And you see they all got a tick box. So you can go through now and just take out the studs that we don't need. There we are. So those are all gone. And that gives us a nice clean board, and then we can go and design whatever we want on it. So let's go and grab a new sketch. Let's put some studs here for the PCB board. Again, this is just a demo, so I'm not doing this accurately. But let's say we want a 5mm standoff with a 2mm screw hole. Extrude that, not that one. Extrude that up for 5mm standoff. Create another pattern. Select that body. We can do spacing, directions that way and that way. We want 2 and 2, and let's just, again, this is just a demo, so I'm not doing anything specific sizes here. Let's do that. So there we've got a standoff for a small PCB board, and then, you know, maybe we need something else in there. Maybe we need something else, I don't know. There we go. So, you know, whatever you want to do, that's the general idea. So I found this very useful. It's made it a lot easier for me to just quickly put together a board or custom Lego piece. I find with the 3D printing, you don't need to do supports. If you've got all of these columns in here, you don't need to do supports. It'll bridge these quite happily, especially with PLA. It works very, very well. If you went into these patterns, where is it? If you went into these patterns and took some of these out, maybe you wanted a cooling hole or you needed a space there, then you probably would need to do supports, or you could just do supports in this particular area. So that is it. Let's put those back. And there we go. So I hope you enjoyed that. I think this is a very useful way of doing a parametric Lego block. Hopefully you can use it in your own designs. It's very, very easy to put together if you follow what I've done here. As I say, they print out really well. I've tested them out on bits of Lego, and I'm very happy with the way that they fit together and press together. So thanks to Christoph as well, who put these dimensions together, which have been really, really useful. So go and visit his site. It looks like he's got some interesting things there. So I hope you enjoyed this video and found it informative. I think that the parametrics in Fusion 360 is really, really powerful. The ability to create a base object and then change it just with a few parameters is absolutely wonderful. I've 3D printed these. As I say, they work very well. So it's all good, I think. And remember, if you want, give the video a thumbs up, especially if you found it useful. It does help. And subscribe if you haven't subscribed already. And hopefully, we'll see you in the next video. Bye.